Okay, the problem is delete the middle node of the linked list. So delete the middle node of the linked list. What is given? You have a given of a head of a list. Delete the middle node, return the head. Simple thing. In the middle node, in case of event node, like see this example, it is a event node 4 by 4. In that case, there are two middle nodes are there actually. So in that case, which middle node you should delete? In that case, n by 2th node you have to delete. Start using 0th index. N by 2 using means say let's say it is a 8th length. So 8 by 2 fourth node you have to delete. So starting from 0, 0, 1, 2, 3, 4. That means these two are the middle, right? These two are the middles. So in this middle, I have to take the second one, right side, right middle. Okay, I have to delete that node. So this is what we have to do. Fine. Then for n equals to 1, 2, 3, 4, 5, middle node should be 0, 1, 2, 3, 0, 1, 1, 2. Like this is the thing. So this is a simple case. So let's see like how could we delete this node. Like for that to delete this node, what actually is starting directly jumping to the approach. How could we solve? Before that, constant are nodes are list range of 1 to 10 to the power 5 and node value could be 1 to 10 to the power 5. So one thing you have to notice, like one node value should be 1. So there is only one single node linked list, like nothing is there. If nothing is there, then see n equals to 1, then middle nodes are 0. So the zeroth node is the middle node. So if it is, let's say this is only the node present, so this is the zeroth index. So that time I have to delete this one. I have to delete. You will see how you can adjust that. So before saying that, let's see a generic solution. These are the two cases we could see. One is the event length, one is the odd length. Okay. So for event length, what we could do? For event length, somehow we need to find this point. This point. So how could we do that? Generally, for finding the middle of the linked list, we use tortoise hare algorithm. Tortoise is the, you all know, you all heard about the story of tortoise hare. That is similar to that. Tortoise hare algorithm is a two-pointer approach. In one pointer is act as a tortoise, that it will jump one node at a time, and another is hare rabbit that will jump two node at a time. So that approach we used to follow. What is the approach is that we generally start our first two pointer in this place. So let's say this is my hare pointer and this is my tortoise pointer. This will, instead of that, we say is a fast pointer, slow pointer. Fast pointer that will jump two node at a time, and another will be the slow pointer. It will jump one node at a time, slow pointer. Okay, so fast pointer will jump two node at a time. So it will start initialize the everything as a head. Now slow pointer will one node at a time. So you can move the slow pointer. This will come in this place. So my target node is this. So my slope, like somehow my slow pointer or something, the fast pointer, anything among the slope or fast pointer, it should end in this position. So how we get this position? So as I told you, fast pointer get two step at a time. This one step to that. Next iteration, slow pointer move one step at a time. Fast pointer will stay two step at a time. So you can see fast pointer is currently at the correct position. But is there any kind of surety, like it do the two jumps, then it will come here? So after that, we don't know the length of the node, so we don't know that. So we cannot say like we are jumping for twice and it will come to the maybe we cannot say that. Can we get any other way so that we can get my I can point out my the middle node, my correct middle node. So let continue my iteration. Slow pointer will jump one node at a time. Fast pointer will jump two node at a time. Okay. Now slow pointer again next point to the one node at a time. This one. Now fast pointer move what? One node here and another node is point to the null pointer. So whenever my fast go into the null, that time my slow pointer correctly point to the correct node. Now in this point what I have to do, what is the previous of the slow pointer? I have to point this pointer to this index. So from here what I could know, like I have to also maintain the previous pointer as well. So that this previous node should connect to the seventh node. Okay, we'll come this previous pointer later. Let's see what is the condition for this odd length case. This is the fast pointer, this is the slow pointer. See, like again let's start our iteration. Slow pointer move one step at a time, fast pointer will move two step at a time. Slow pointer will move one step, fast pointer will move two step. Now slow pointer will move again one step. Now fast pointer will move two step. See here, for this case, this is my middle actually. This is my middle. So notice one thing. For the second case, if it is odd, if it is a even length, now fast pointer becomes null. So, but if it is length is odd, fast pointer is not null, but the next of the fast pointer is null. So in any case, if any of these are true, if fast pointer is not null, but fast pointer dot next is null, then we will stop. If fast pointer becomes null, then we will stop. Hope you are getting it. There is two things you have to observe. Observation is when, like, it could be my odd length or even length. Apart from them, there is no other possibilities. Correct? So if it is an odd length or even length, it doesn't matter. So for even length, what I am saying here, for even length, when my slow pointer comes at the correct middle value, my fast pointer becomes null, right? In the odd length, what we are saying, when my slow pointer comes in the correct middle value, my fast pointer is pointing to the last node. So what is the property of a last node? The next value of the last node is a null. But the thing is, now you can ask me, like, how could we know uh, it is a last node, like it's an odd length or even we don't know it's an odd length and even length, and even we are not counting, we don't put a count of that, so we're not a counting of that. So we will make a condition like, see here, if it is a even length, if it is a even length, fast pointer always end as null. There's no other way, like fast pointer can point this position, it is no other way. So the thing is, fast pointer, if you notice, fast pointer move two step at it twice. So fast pointer, if I write the fast pointer, reassign the fast pointer, it will so fast dot next. This is how we write it, right? So it will move two step at a time. But notice here, in this case, whenever I fast dot next, if my this part becomes null, if this part becomes null, then this part, then if it is becomes null, then this part, let me use another color, then this part will throw me an error, because if it is null, then it gives me an error, because null dot next is not a valid pointer, not a valid thing. It will give us an error. So that thing is, we have to check whether fast is null or not. If fast becomes null, that means what? It fast pointer becomes in a null pointer. That means fast dot next, this one will give a null. But what we notice, like, if fast becomes null, that means what? I become at the end of the fast pointer becomes at the end, and that means fast becomes null. That means it is a even length. So current slow pointer is the correct form. What is fast dot next is not null. What is fast dot next is uh, what I am saying. What is this is, if fast is not null. Sorry, my bad. So I am saying if fast is null, that means what? I traverse all the nodes, and that means fast becomes null. That means my linked list has the even number of nodes. What if fast is not null? If fast is not null, that means it could be this one and this one. There are two possibilities. Fast is not null means there are two possibilities. It could be the last node or could be the intermediate node. Correct. So in that case, that means if fast is not null, that means it has a one valid thing. Like it has the dot next value is something is there. Dot next is there. Dot next is there. Now think of it. If this thing, if this somehow this fast pointer is this point, then this is a valid argument. Fast dot next, because fast is this one. It has some next value, and it has also some next value. So it is a valid thing. That time fast becomes null. But if somehow fast is pointing to this pointer, that means there are two cases I told you. Like it could be this in this node, last node, or it could be intermediate node. If it is an intermediate node, then this is this case. At the next iteration, fast becomes null. So that means it is a even length. So if it is odd length, when this case will arrive, that fast dot next equals to null. So if fast dot next equals to null, then we cannot do that null dot next. It is not a valid one. This will throw an error. So that means fast dot next equals to null. That means what? Like it's an odd length index. So only the odd length, like fast came to the last node. You can take any example, you will see like it will never possible in the even length of linked list. This fast will point to the last node. It is never possible, but it is possible. Like if we initialize fast and slow pointer at the head position, in that case, it is never possible. Fast will in the even length case, fast will never point to the last index. Similarly, if we both start slow and fast pointer start from the head pointer, it is never possible fast will come at this place. It is never possible fast will come the second last node. It's never possible with that. So you can try any cases. It is not possible. So I have to check two cases. While fast is true, if fast is not true, that means fast comes at last position. That means I come at the next index, so I can stop. Or if it is like it is true and fast dot next is also true, because see here I am staying here, fast is true and fast dot next is also, I have some valid thing. If my fast dot next becomes null, that means what, I also have to stop. So there are two cases. If fast becomes null, that is the case, and also like fast dot next also becomes null. Otherwise, I like for fast each iteration, fast need to move by this way. Fast dot next. To write this thing to check, wait a minute, to check this is a valid or not, to check this one is valid or not, there should be two cases. One thing, fast cannot be null. If fast cannot be null, one case. Another case is fast dot next cannot be null. If fast becomes null, then fast this argument becomes invalid. This argument becomes invalid. And if fast dot next becomes null, then this argument becomes invalid. Dot next. Hope you are getting it. So that's why we will loop until whether fast is there and fast dot next is there. In that case, we will traverse. If anything is not true, then we will stop. That means fast either reach in this position or fast either reach in this position. In the both cases, we will get our actual slow pointer. That same pointer I want to delete. Okay. Now what I have to do for the deletion? For deletion, after deletion, this for this case or even case, this 8 should point to the 7. And for the odd case as well, this 8 should point to the 7. So how could I get this 8.881? So this is a single linked list. Cannot get my if it is double linked list, I can simply go to the previous and put in the dot next. Not there. So I need another pointer, previous. A previous pointer simply just it will point to the, if the previous pointer simply point to the previous node of the slow pointer. In that same class, I will with another pointer previous, it will simply point to the next pointer. That is, as right, previous dot next. What is the pointing this next? It will point to slow dot next. Simple that. Okay. Okay, I have to charge my plug in my laptop. Just a second. Okay, so this is how we have to do. So hope the process is clear to you. So let's write our function. Let's say function delete. Let's say delete middle. What is given? My head is given. Head is given. Okay. So what we will do right now? So what I was saying. So I need two pointer, fast pointer and slow pointer. So one is slow pointer, which will initialize with head, and another one will be the fast pointer. This will be also head, and I need another thing, that is previous. I will initialize the null value right now. So what I told you, while my loop will do until while it is fast, it is valid, and fast dot next is also valid. Both are not null. If that is the case, I will continue. What I will do continue? So previous, if I do from the beginning, So this is the fast pointer. This is my, let's say this is my fast pointer and slow pointer, and this is my previous is currently null. So what I'll do, after this iteration, this slow will move in this place, fast will move this place, right? Now the previous should move this place, right? But if I move slow fast, then if I move slow fast, then I have lost the thing. So what I'll do, I will assign the slow. I will assign the slow as the previous in the previous. So current is nothing but this is my current pointer. This will move one step at a time, right? This is nothing but a current pointer, you can think. So this current become my previous, and then I will move my current one step forward. Correct. So I will write previous equals to slow. Then slow will become move one step at a time. Slow dot next. Slow dot next. Now my fast will move two step at a time. So fast equals to fast dot next dot next. And no need to explicitly check, because for fast is true, for this is true, for that, for become this as a kind of valid thing, like fast cannot be null. That's why I checked here that fast cannot be null. And after that, after this fast becomes true, this fast becomes true. Now this whole thing becomes true. For fast dot next not be null. This one also, this fast dot next cannot be null. This one also, fast dot next cannot be null. So that's why I have checked explicitly fast dot next is also not null. Until both are the case, I will iterate the I'll iterate. Okay, I will simply iterate. Okay, so this is what I will do. Fast wait a minute. Fast dot next. Okay, fine. So this is how I am done. So after end of the loop, what I noticed, what I noticed, like at the end, my slow will become here, fast will come here. So at the end it will fail because fast dot next equals to null, and previous is this one. So my previous value, I have to assign this previous value. Previous dot next will be my slow dot next, slow dot next, slow dot next. And after that, what will happen? And what will happen? This will become, I will return my head. Return my head. This will become my current head. So there is one catch also. Return head. Simple that. But there is one catch. Catch is like if there is only one pointer. One. This is my head. This is my head. If it is only pointing to the nothing, like one only there, only one is there, you can think two cases, only one and two. If that is the case, you think, let's say one and two. Let's say it is my slow pointer, this is my fast pointer. Even if it is a work, how it work? Why do you see fast is a valid, fast the next is also valid. So slow will move this pointer to this pointer. This is my slow. Okay, this will become my previous, and this fast will move this place. Null, right? Null. So this time it will be there. So that time previous or next, previous will point to this null pointer. So it's fine. So then this is my head. So it will pass. Fine. So what will be the, if it is single case? What will be the single case? I can single case. If I do the single case, if it is my slow, this is my fast. In that case, what will happen? If I do these things slow handed, this loop will not work because fast dot next is a null, so it will not work. At the end, previous is tried to previous dot next equals slow dot next. Next is null, but previous is also null. Na? Here previous is also null. So this step, previous dot next equals slow dot next, this will throw an error. So this is one edge case. The edge case, what we have to handle, if my head is null, so we have to handle this way. If my head dot next equals to null, if head is null and next pointer is null, so then I will simply return none. Return null. Because see, if I delete this thing, now head will point what? Head will point a null value, right? It will point the run value. So that's why I will simply return null. So that's all. That's the only edge case of this problem. Hope you get this thing. Now let's see what is the time complexity. This is while loop is nothing but, see, a slow pointer is taking one step at a time, so it is traversing half of a node. But fast pointer is hopping 2 times. So it is also like, it is not, it may seem like fast is traversing big of n time. It is not big of n times. It is taking 2 steps at a time, right? So 2 steps at a time, that means n by 2 times. And slow pointer also taking n by 2 times. So time complexity is big of n by 2. Time complexity is big of n by 2. Are we taking any other thing? No, rest of the things are big of 1. So time complexity is here big of n by 2. So if you divide by 2, is you can ignore, then it's a big of n. But I am writing as n by 2 because it is strictly big of n by 2. And space complexity is, are we using any extra space? No, right? We are using only pointers, so it is big of 1. That's all. So this is very simple problem. Hope you get it. And as always, if you find any mistake in this approach, please let me know so that I can rectify. And if you find any useful information on this topic, please also let me know so that I can learn. Thank you. Bye bye.